dt dx is equal to, if you differentiate this root over x square plus 4 by 4, you take 1/4 out first and then differentiate the radical. Okay, so you get into 1 by 2 root x square plus 4 into the ddx of x square plus 4, which is simply 2x. Next, plus 1 by 6 you take out, and then you differentiate 4 minus x. You get 0 minus 1, which is simply minus 1. So this 2 and this 2 cancel here, so that you get dt dx as x by 4 root x square plus 4 minus 1 by 6. This is what you get as dt dx. So for maximum or minimum t, you must have dt dx is equal to 0. That means x by 4 root x square plus 4 minus 1 by 6 is equal to 0. You take 1 by 6 on that side and you cross multiply. So you'll get 6x is equal to 4 root x square plus 4. Now to remove the radical, you square both sides. You get 36x square is equal to 16 times x square plus 4. So you get 36x square is equal to 16x square plus 64. Okay. So now you solve for x here. You get 36x square minus 16x square is equal to 64. 20x square is equal to 64. X square is equal to 64 by 20. Okay, so you can cancel here. 16 times, 5 times, you cancel with 4. That means you get x is equal to square root of 16 by 5. That means you get x is equal to 4 divided by root 5. Okay. Now we are not taking the negative sign because x is the distance. Distance cannot be negative. That is why we have not taken the negative sign. Okay. Now once we have got x, at x is equal to this, the time taken will be either minimum or maximum. Now let's check whether it will be minimum or maximum. That means we now find out the second derivative. Now second derivative has to be found with a little bit of patience. d2t dx2 is equal to ddx of dt dx. Is equal to ddx of, and if you see above, dt dx is x by 4 root x square plus 4 minus 1 by 6. This was dt dx that we had found out. Okay, so now you start differentiating. This is equal to simply ddx of, you can take 1/4 out, x by root x square plus 4, and ddx of 1 by 6 is clearly 0. So you don't need to, you just need to differentiate this. How will you differentiate this? You can differentiate this by u by v root. Okay, if you differentiate, if you check the differentiation, u by v here is root over of x square plus 4. So this is root v into ddx of u here is x. So ddx of x here is 1. So that nothing to write here. Okay, minus u is x into ddx of v. V is root over of x square plus 4. How do you differentiate root over of x square plus 4? First you differentiate the radical. And then you differentiate what is within the radical. Okay, divided by v square. V square here is root over of x square plus 4 whole square, which is equal to, now you simplify this, take the LCM in the numerator. If you take the LCM, first of all, this 2 and this 2 are going to cancel here. And now if you take the LCM, you're going to get x square plus 4 minus x into x will give you x square divided by root over of x square plus 4 divided by x square plus 4. Right? Now you take root over of x square plus 4 in the denominator and write it as x square plus 4 to the power of half. You will get here. Now see here, this x square and this x square will cancel here. Okay, so what you are going to get here is 4 by 1/4 into 4 by x square plus 4 to the power of 3 by 2, which is equal to, now here 4 and 4 cancel. You simply get 1 by x square plus 4 to the power of 3 by 2. Okay. Now we need to check the sign. What is the value of x here? At x is equal to 4 by root 5. d2t dx2 is equal to 1 by, put the value here, 4 by root 5 x square plus 4 to the power of 3 by 2. Now, irrespective of the value, you know this will be positive, right? So, thus, t has a local minima at x is equal to 4 by root 5. So, time is minimized when x is equal to 4 by root 5. And what is x here? X is the distance which is reaching on the shoreline after swimming, a distance of not swimming, in fact rowing, a distance of AP, right? So you have to find out x. We have found out x. Hence, the storekeeper must reach the shore at a distance of 4 by root 5. If you see, the answer is, I think, given here in terms of okay, 3 root over 3.2. You can convert this to 3.2. Okay, you can write this as root over of 16 by 5. Which you can write as 32 by 10, which is square root 3.2, which is equal to 1.789 kilometers. So the storekeeper must reach the shore at a distance of 4 by root 5 equal to 1.789 kilometer from the point to minimize his time. Okay. So I hope this is clear. Can move on to the next question then. Any questions on any step? Do number 12 then. Okay, we'll do number 9 then. I had skipped 2 problems and I did not do number 9 and 10. I think I forgot. A wire of length L is cut into 2 portions which are divided into shapes of a circle and a square respectively. Show that the sum of the areas of the circle and the square will be least when the side of the square is equal to the diameter of the circle. Okay, so you have a wire here. Let's say this is your wire of length L. Okay, and this wire is made into a circle first, and also a square is also made from this wire. Okay, so 2 shapes are made, one a square and the other a circle. Okay, now let us assume that X part of this wire is used to make the circle and the remaining L minus X part is used to make the square. Okay, that means if X part of the wire is used to make this circle, that means circumference of the circle must be equal to X, right? L minus X part is used to make the square. That means perimeter of the square is L minus X. So what should be each side of the square? It should be L minus X by 4, right? So we start by saying, let the length of the wire let X be the length of the wire with which a circle of radius R is made. Okay. So also what is given here? Given here is length of the wire equal to L. So if the length is given, that means L is a constant. Okay, now if the X part of the length of the wire is used to make the circle of radius R, therefore 2 pi, let us write this as radius is R. Therefore 2 pi R must be equal to X, right? That means we get here R is equal to X by 2 pi. Here X and R both are variables. Are both variables. Now, therefore, what should be if L X part is being made to use the circle, as I told you, L minus X must be the perimeter of the square. L minus X is the perimeter of the square. That is what is each side of the square? L minus X by 4. Right? So each side of the square here is L minus X by 4. Okay. Okay. Now, if you see here in the question, it is given to you that show that the sum of the areas of the circle and the square will be least when the side of the square is equal to diameter of the circle. That means you have to minimize the sum of the area of the circle and the square. So let us find out the sum of the areas of the circle and the square. Sum of the areas A. What are the sum of the areas? Pi r square plus L minus x by 4 whole square. This is the sum of the areas. Now write R in terms of x. You know R is equal to x by 2 pi. Call this 1. Right from 1. So if you see we had two variables here, R and X, we brought it down to a single variable. Okay, let's simplify this a little. Okay, this is the sum of the areas. So we need to minimize A. Or is it maximize? Yes, minimize. So that the sum of the circle and the square will be least. So we need to minimize A. How to minimize A? dA dx. 1 by 4 pi into 2x plus 1 by 16 into twice differentiate L minus x square, you get twice L minus x into minus 1. Okay. So what you get here is, this will cancel here. So you will get x by 2 pi, and this again will cancel here 8 times, minus L minus x divided by 8. This is what you are getting as dA dx. So for maximum or minimum A, area A, dA dx must be equal to 0. That means x by 2 pi minus L minus x divided by 8 must be equal to 0. Okay, so you find out x from here. So x by 2 pi is equal to L minus x divided by 8. Okay. So now if you see, you can cancel this 2 here 4 times. Now you cross multiply, you get 4x is equal to pi times L minus x. That means you get 4x is equal to pi L minus pi x. Means you get 4x plus pi x is equal to pi L. Means you get x times 4 plus pi or pi plus 4 is equal to pi L. That means x is equal to pi L divided by 4 plus pi. This is the value of x. At this value of x, the area is either minimum or maximum. Now we need to check whether it is maximum or minimum by second derivative test. So therefore, d2a dx2 is tdx of dA dx. ddx of dA dx here is x by 2 pi minus, let me give box brackets, L minus x divided by 8. This is dA dx, which is equal to ddx of x by 2 pi is simply 1 by 2 pi, right? 1 by 2 pi into ddx of x, which is 1, minus 1 by 8 ddx of L minus x, 0 minus 1, which is minus 1. So you're getting 1 by 2 pi plus 1 by 8. What is the value of x? At x is equal to pi L by 4 plus pi, what is the sign of the second derivative? d2a dx2 remain the same, 1 by 2 pi plus 1 by 8. which is greater than 0. What can we say? Thus A has a local minima at x is equal to pi L by 4 plus pi. Okay. So what do you have to show here? You have to show here that the area will be least. So we have minimized the area. Area will be least when the side of the square is equal to the diameter of the circle. Okay. Side of the square is equal to diameter of the circle. You have found out x, right? So what should be the radius of the circle? From 1. You can find out the radius. Therefore, radius of the circle r is equal to, what was the expression? X by 2 pi. Put the value of x here. 1 by 2 pi times pi L by 4 plus pi. This pi cancels. So you're getting L by twice 4 plus pi. Okay. This is the radius of the circle. So the diameter of the circle is 2r, which is equal to 2L divided by twice 4 plus pi, which is equal to L divided by 4 plus pi. This is the diameter of the circle. You need to show that this diameter must be also be equal to the radius at x is equal to pi L by 4 plus pi. So we have found out the diameter. Now let's find out the side of the square. What is the side of the square? L minus x by 4. Each side of the square L minus x by 4. Put the value of x. 1/4 of L minus x pi L divided by 4 plus pi. Simplify this. 1/4. Take the LCM. 4 plus pi into L minus pi L divided by 4 plus pi is equal to 1/4 4L plus pi L minus pi L divided by 4 plus pi. Pi L cancels. So you get 1/4 of 4L times pi plus 4. Again 4 and 4 will cancel. So you get L divided by pi plus 4. So what you see here, that the diameter of the circle is L by 4 plus pi, and the side of each side of the square is also L by 4 plus pi. Hence, area, sum of the areas of the circle and the square is least when side of the square is equal to diameter of the circle is equal to L by pi plus 4. Hence proved. Any question here?
No, sir.
You are understanding everything. You should have questions from maximum minima. This is not an easy part. Let us understand the next question and then I can proceed with the solution in the next class, that is next week. And next week, Monday, as I gave you I think you'll have a test, I think next week, Monday, right?
Yes, sir.
Yes.
Yes, sir.
We can continue on Tuesday. Let us understand this problem at least before we split. Um, the question here is, find the dimensions of the rectangle of greatest area that can be inscribed in a semicircle of radius r. So let us draw a semicircle. You have a rectangle inside this semicircle. Okay. ABCD is a rectangle that is inscribed within this semicircle. Okay. Now they are asking you, and also they have given you the radius of the semicircle. So the radius of the semicircle they have given you as, let us call the center as O. The radius they have given to you as R. Yes. Okay. You have to show that the dimensions of this rectangle, you have to find out the dimension. That is, you have to find out the length and breadth of this rectangle such that the area of this rectangle is maximum possible. Okay. When is the area of this rectangle maximum possible? When uh, when length is equal to something and breadth is equal to something. That is what you need to show. Now, what you must realize here is that the radius is given. So this length here, if I call the 2 points here P and Q, okay. So OQ is given to you as R. In fact, OP is also given to you as R. Also, what you must realize is that if you join this also becomes R, right? This is also the radius. Now, if I say that let the length and breadth of the rectangle be L and B, then which one will be L and which one will be B? This one will be L. This part will be L by, wait, this part will be, this part will be B, right? And what else can you say about the other parts? Um, yes, if I am taking this part as L, that means this part will definitely be L by 2. OB will be L by 2. Check whether you understood this.
Yes, sir.
So which one is a variable, which one is a constant? Can you tell me before I leave?